Aloha, Kat. Aloha, Denise. So this is hopefully a little bit of instruction on how to put a formula into Excel and use the power of Excel to kind of evaluate this. This will help with both the converting magnitudes to fluxes on our WISE data, as well as doing the blackbody assignment as well. So feel free to follow along, whatever. If you have Excel open, you can go ahead and get started. And what I'm going to do is in our little demonstration here, I'm going to graph the function y equals, or actually, well, we'll go ahead and do a little graphing as well. But I'm going to go ahead and come up with data for the function y equals x squared minus 3x plus 4, just as an example. So the function maybe that we're interested in instead is taking our data and computing the fluxes. In that case, the formula I would be using would be the magnitude to flux conversion formula, or the blackbody Planck's law if I was going to do the blackbody curve. So what I'm going to do here is I'm going to set up a little table, and we're going to have some x values and we're going to have some y values. Now the x values, I'm going to pick just several different x values to give me basically the domain of the curve that I'm sketching to come up with the results here. So maybe I'm going to go through and maybe we'll start at minus 3, and then we'll go to minus 2.5, and then we'll go to minus 2. And of course, if you're building something that has a pattern in Excel, you can click on the lower corner there, drag down, and that will automatically fill in and continue your pattern. So these are the x values that I'm going to graph this particular function at, and so we're going to get some data points basically from these particular values. So the key here is to enter the formula in here, but we're going to reference these other cells. We're going to reference where the x coordinates are when we go through and do this. So for example, I want to do x squared here. I'm going to set up equals. First of all, that lets Excel know that I'm actually going to be putting a formula in and working to have Excel do some computations for me. I need to take my x coordinate and square it. That's the first thing I need to do for the first term in this expression. So what I'm going to do is I'm going to choose this cell right here as my x coordinate. So you notice I clicked on that, and now the cell reference, the D8, shows up right there as the value that I'm computing. That's my x coordinate, so I'm going to square that. And then we're going to do minus 3 times that x coordinate yet again, and then we're going to add 4. And now as soon as I hit enter, it's going to actually do the computation for me. It's going to show me that the y coordinate that goes there is 22. There's a very easy way once you have a calculation set up. So for example, the calculation I have right here applies this x value right here. If I want to do this down here now with a different x value, minus 2.5, I don't have to type the entire equation over again. Rather, if I come down here to the corner of this cell, you can see that the big plus sign changes to a small plus sign. And if I click when my mouse icon looks like that and I drag down, what it's going to do is it's going to copy this formula for all of these locations. And so each cell now, you can see if you look up here in the entry line, this formula is now applied to D9, which is this point right here. We can come down here, you can see that this is applied to D12, so on and so forth. So we have our x and our y coordinates here. We've actually been able to do a calculation. You could do exactly the same thing if you were, for example, doing the fluxes, right? The x values would basically be the magnitudes that we got off of the WISE data, and then you would plug that into the formulas for converting those to fluxes, and then you could copy that formula down for all the sources in a given location and compute those up. Now we don't need to do this here, but another thing we're going to need to do in our program later on is to sum up all of the fluxes. So suppose I want to figure out what all of these numbers added together are. Well, I can do another formula for that. And what I can do here is say equals, and Excel has a particular formula called sum, and what sum does is sum will sum up all of the cells that you highlight. So if I highlight all of these cells, then Excel will compute their sum, and it turns out to be 122. Now this doesn't really have any meaning for us because this is simply the sum of the y coordinates. That's not something useful here, but definitely would be something useful when we're working to find the total flux at a Planck data point that's composed of lots of y's data. But if I wanted to graph this information, now if I wanted to come up and graph this information, maybe you guys already know how to do this. What I would do is highlight the data that I'd like to graph. So I'd like to graph both the x and the y. And for me, the graphing utilities are under the Insert tab up on the menu here. And we can choose from a variety of different graphs here. I'm going to go ahead and choose a scatter plot. I'm going to choose a scatter plot with smooth lines. I know this is a well-defined function, so I can go through and compute this with nice curves here. And you can see we get a nice graph. Excel gives us a nice graph of our function, and we can actually then go ahead and do some other things with it. We can change the type of layout we have. Excel has lots of options for doing different things. So what I might do is put on a chart title here and call this the graph of y equals x squared minus 3x plus 4. And then we can go ahead and put on the axis, our horizontal axis is x, and our vertical axis is y. So that's a very, very short introduction to some things that we need to know how to do. Please email me with questions. You know, this takes just a few minutes to throw together something like this. So if you're if you need a little bit of extra help, or if I glossed over anything too much, please don't hesitate to let me know. Otherwise, hope you're having a great time. Go Cold Spots!